for the following pair of functions, find the domain of the quotient g divided by f of x. And we are given two functions here. We have f of x and g of x. So the first thing that we want to do is find the domain of both of these individual functions. So in other words, we want to find the domain of f and g. And so both function f and function g are rational functions here. So let's quickly recall that for a rational function, division by 0 does not exist. So to find the domain, we need to set that denominator not equal to 0 and solve for x. So here we go. The first function that we're working with is f of x is equal to 2x all divided by x minus 1. So to find this domain, we are going to set that denominator x minus 1 not equal to 0, and we'll solve for x. So to solve for x here, we are going to add 1 to both sides of this equation. So minus 1 plus 1, those cancel each other out to 0. And so we can see here that x cannot be equal to 1. So this is the first undefined value that we want to keep in mind. And very similarly, we now want to go ahead and consider our second function here. This is g of x, which is defined as 4 all divided by x plus 7. Now again, to find the domain for g of x, we're going to set that denominator, x plus 7, not equal to 0, and solve for x. So here we go. To solve for x, we're going to subtract 7 from both sides. So 7 minus 7 cancels itself out to 0. And we can see here that x cannot be equal to negative 7. So here is that second undefined value. So both of these values are going to be excluded from the domain of the quotient of the two functions. But we can't quite state the domain yet, because we need to see what the quotient is and if there are any other undefined values. So here we go. We want to find the quotient. So we are asked to find g by f of x. So the first thing that we want to do here is just think about the definition. How can we simplify this? So let's expand this out. We have g of x all over f of x. And now let's plug in the functions we're given. So we have 4 by x plus 7. There's our g of x function. And this is all divided by f of x, which is 2x divided by x minus 1. Now, notice that we have a fraction in the denominator. So we know that this must flip, or we're going to multiply by the reciprocal. So this becomes 4 over x plus 7. And this is now multiplied by the reciprocal of the denominator, which will be x minus 1 all over 2x. And so now we can simplify. This is, oh, look at this. We can simplify our two numerical values. We know that 2 goes into 4 2 times. Now, nothing else is going to cancel, so we can rewrite our answer here as 2 times x minus 1. And that's all over x plus 7 multiplied by x. So, therefore, our beautiful final answer here for g by f of x is equal to 2 times x minus 1 all over x times x plus 7. And now we know by definition of a rational function that our denominator cannot be equal to 0. So this means that x times x plus 7 cannot be equal to 0. Now, we already know when x plus 7 is not equal to 0 that we'll see x cannot be equal to negative 7. We're already excluding that value. But notice that we have this extra value here. So we need to think about that factor of x as well. Want to make sure we can see both of our exclusions. So x times x plus 7 cannot be equal to 0. We have two separate cases to consider here. We have this new factor, x cannot be equal to 0. So we'll want to be sure to exclude this from our domain. And again, we've already seen that when x plus 7 is set not equal to 0, that this produces x cannot be negative 7. So there are three values here that we need to exclude with our beautiful final answer here for the quotient. So that's our final answer for the quotient, and we're ready to think about the domain. So we can say that x can be all real numbers, except x cannot be equal to 1, x cannot be equal to negative 7, and x cannot be equal to 0, as we've just discovered. So how are we going to write this beautiful final answer in interval notation? So we can think about a number line to get us started. So this is the x number line. And let's simply add these three undefined values to this number line. So we'll say there's negative 7, there's 0, and there's 1. So it's certainly not to scale, but it gives us a good idea of what we need. So we know we cannot be these three values, so we'll draw open circles there to indicate we need to exclude these values. So we're excluding these three x values, but x can be any other real number except those. So let's shade in those regions. So x can be any of these numbers from negative infinity. So this is from negative infinity to negative 7. We know that x can be any number from negative 7 to 0. So that means we can also include this interval, negative 7 to 0. We know that x can be any real number between 0 and 1. So there's another interval from 0 to 1. And last but not least, x can be any real number greater than 1, all the way extending towards infinity. So infinity is not a real number. It represents the continuation of numbers. So that's why we use those open parentheses there. Now, we can't just leave our domain like this, these four separate intervals. We need a way to unite them. So to unite them, we add the union symbol. So we are uniting these four intervals. And so this gives us the beautiful final answer for the domain of this quotient of functions.